The dot on the diagram represents a skier as she passes point B. Draw and label the vertical forces acting on the skier, right? So when they reach this spot here, remember that they're moving this way, right? That's the direction of their velocity. Remember also that they're accelerating down. This is their centripetal acceleration, because to follow this curved path means that you're going in a circle. And when you're going in a circle, you're always accelerating toward the center. Okay, so let's figure out, let's do this one first, and then we'll be able to draw these arrows, okay? So the hill at point B has a circular shape with a radius of 20 meters. Determine whether the skier will lose contact with the ground at point B. I think the easiest way to do this is to figure out what their acceleration is, right? Remember that they're going 12 meters per second, right? So the centripetal acceleration is going to be v squared over r, right? So 12 squared divided by 20 is 7.2, okay? So I'm getting an acceleration of 7.2 meters per second squared, which means that the skier does not lose contact with the ground. And the reason for that is, of course, that this acceleration, if the centripetal acceleration ever had to be greater than 9.81, of course, the only thing holding them down, assuming they don't have like wings or something like that, right? The only thing holding them down is gravity. And if the acceleration needs to be bigger than the acceleration of gravity, then they will lose contact with the ground. So when you watch the Olympic skiers and they go over curves like this, that's what's happening. When they lose contact with the ground, it's because to follow the curvature of the ground, you'd have to accelerate down faster than 9.81. And that's just not possible unless you have like wings, like an Indy car or something like that, right? Okay, so you would make some argument here. You'd calculate the acceleration. You'd say that acceleration is, what, less than 9.81, right? And so therefore, no, they don't lose contact with the ground. Now, they almost do, right? Okay, so, it's like, so what you're going to do is you're going to, it said, the question here says, draw and label the vertical forces acting on the skier, right? Okay, so let's, just for kicks, let's draw those forces, right? So at that point there, right, you've got the force of gravity down, right? Okay, but the surface is also pushing up. Notice that the surface doesn't have to push up very much though, right? Okay, because they're almost losing contact with the ground, right? So we've got an upward force like this, right? So this is the weight of the skier, right? This would be the reaction force, the surface pushing up, right? Notice that the reaction force is less than the weight, and that's because the person's accelerating down, right? So you need less force up, and they're accelerating down because they're following that curved path.